Hey kiddos, so this is for lesson 10, rigid transformations. Your learning goal is let's draw some transformations. So in our warm-up 10.1, notice and wonder transformed. What do you notice and what do you wonder? Let's see, I notice that I only got a point over here, right? And go ahead and try to figure out what else you notice, if you notice anything. All right, what do you wonder? Okay, so hopefully you paused the video and you took some time. I noticed that S could reflect over a line M here, and it would map perfectly onto object M, right? You guys see that? And then I also noticed that if you look at object S compared to object D is twice as big as object S, right? And what about the distance from O to D compared to point O to H? What do you notice about the difference in distance between O to D and O to H? Huh. You can even do the same thing with all the other points, like O to A compared to O to E. What do you notice? What about O to C, right? And then O to G. And then what else? O to B, point B, right? And then O to point F. What do you notice? Right? Yeah, there you go. All right, activity 10.2. What's the same? So draw and label each rigid transformation. All right, so number one, we got to translate figure S along the line segment V. Line segment V. All right, well, we're going to have to figure out what that is because all I see is W. You guys see that? Along line segment W, perhaps, in the direction shown by the arrow. And the only ray or arrow that I see here, right, is labeled W. All right. Translate the figure S. So we have this object, and I just scribbled all over it. Start over. Can I, let's see, ooh, shape. Okay, so let's see. Translate figure S along the line segment W, because V doesn't exist, in the direction shown by the arrow. Okay, so if we look at, let's do shape, okay. Do you see this point right here? It's going to have to move the same direction as the arrow says. So we have to go 1, 2, 3, 4, 5 diagonal lines down. So let's try going 5 diagonal lines down. 1, 2, 3, 4, 5. And let's see, S right here is two tiles up from point vertex to vertex. And then it's 2 triangles up to the right. And then down 1, over 1, and then down 1, and then over to finish the tile. So what do you guys notice? So let's call that figure T. All right, figure T. All right, that is T. T. Okay, so that's figure T. Now they say reflect figure S across line Y. Oh, okay, so we got to reflect. Now, if we were to reflect, okay, let's look at this point right here. How many triangles is it away from Y? 1, 2, 3. So if it was going to reflect, it would have to be 3 on the other side. 1, 2, 3 for our first point. So let's go ahead and do shape again. Let's see, 1, let's make sure I don't mess up again. 1, 2, 3. and then down to over here. Oops. Oh, it erased everything. Okay, let's do this over again. So 1, 2, I'll tell you what, I'm just going to focus on the reflection, okay? Sorry about that. 1, 2, 3, 1, 2, 3. 2 down, there we go. 2 immediately down, 1 up to the left a little bit, 1 straight up, and 1 up to the left. There you go. And I'll label that, let's see, I'll label that TU. Because the other one was T, right? The other one that didn't survive. So that's a reflection right there. Okay, that was a reflection across line Y. So S gets reflected across, like a mirror, like a reflection. Okay, so that's going to be figure U. All right, reflect figure S across line M. I don't see a line M. Yeah, I don't. So that's going to be an issue there. Translate figure S along the segment W in the direction shown by the arrow. Reflect the image across line. Huh. Yeah, apparently these instructions do not match up, so that's not very nice. But the main two movements that you should probably notice is what translation looks like and reflection looks like. So S to U is a reflection. A translation, again, I'll draw it. Remember, we had to basically go the same direction, 1, 2, 3, 4, 5, down and to the right in order to create T. And I'll do that again. So, oops. All right, so we had to go 1, 2, 3, 4, 5. And the object still stays the same, right? So here from here, up 2, down 1, down to the left, down 1, down to the left. All right, and that was what T looked like for the translation. The translation, it's a movement, right? What do you notice about the size of the shapes after I did a translation to create T, after I did a reflection to create the new figure U? What do you guys notice about S, T, and U? Right? What do you notice? Okay, so how are the images the same? How are they different? Well, S and T are very, very similar, right? Like even their orientation, like the way they're positioned, is very much the same. U, on the other hand, still has the same dimensions, just is it facing the same direction as S was originally? Okay. Let's see, activity 10.3, does order matter? Here are 3 congruent L shapes on a grid. Describe a sequence of transformations that will take figure A onto figure B. Okay. Let's see. What if I reflect? Oh, whoa. These tools are interesting. Let's see. Do I have to click on the shape? No. Okay. If I reflect, hmm. Oh, okay. I see what they did there. What if I did, oh, there we go. That's how it works. All right. So figure A. And then what if I translate it down? Nope. See how it doesn't map on? So if I translate down, what, 1, 2, 3, 4, 5, 6, 7 tiles, and to the left 2 tiles, notice that doesn't map on. I'm gonna have to use, I don't know, maybe what if I use a rotation? What if I use a rotation, right? Like, do you see this point right here, or like right here? Maybe I can do a rotation. So let's see what that looks like. Okay, the center, maybe right here, maybe, or maybe right here, or very debatable, right? And the angle, let's try a good old-fashioned 90 degrees. See what that looks like. Nope, not quite. Double it. 180, 180 degrees. Oh, it doesn't quite map either. You guys see that? Now, I like the idea of just using one transformation. Maybe it's possible, maybe it's not. What if I use two transformations? So let's pick that object, and I'm going to reflect it like this, and it'll match. Okay, can't really see it, can you? So how about this? How about we do the reflection first? Okay, I'll reflect it right there. See, I did a reflection from A to the green object. And now I want to do a rotation. I'm going to move it center right here, center of rotation. And then I'm going to pick this object here. 60 degrees is the gray shaded area. It needs to swing a little bit more. 90 wasn't enough, remember, so I'm going to do 180. Spin it all the way around. And there it is. I just mapped it on. So it looks like from figure A to B, we had to do a reflection, right? Then rotation, and we had to rotate counterclockwise, right? Counterclockwise 180 degrees, right? So that was what the two things I had to do in order to get figure A to land perfectly on figure B, or to map onto. What about if you reverse the sequence? Will you reverse the sequence still to take A onto B? If I reverse it. So what if we did counterclockwise 180 degrees first, and then we did the reflection? So let's test that theory. So first things first, let's do a rotation. All right, our center was over here, wasn't it? We did 180 degrees. Okay, now can we do a reflection and still be okay? Let's find out. Let's see if we can do a reflection real quick. Yeah, see? You do a reflection, it maps perfectly onto B. So yeah, we can in this situation. Okay. What's our next question? Describe the transformations for figure A onto figure C. Okay. I wonder. I feel like it's a pure reflection. Let's see. Let's pick this object, right? Figure A to C. And then what if, no, well, almost, right? So let's see, maybe I need to adjust my reflection line. Oof, almost. Getting better. Maybe around there. Oh, we're getting closer and closer, aren't we? Here we go. Almost. Oh, we're getting so close. You guys see it, right? Like, oh, we're getting so close. So notice I'm reflecting from A, trying to get it onto C. I'm having a tough time trying to get it there, though. All right, so maybe it's more than just a reflection. Maybe I have to use a sequence. Maybe I have to use 2 movements instead of 1. So I'll tell you what, we'll do a reflection first, okay, around that line. And then I want to go ahead and do a translation. So the green one's right there. And I'm just going to move it up. How much do we move it up? 2. Yeah, see, 1 tile, 2 tiles. There we go. Now it matches up. So we had to do a reflection first to get from here to here. Then I did a translation up 2 spaces. Now, I wonder if they're going to say if we reverse it. If we reverse it, let's try that. So let's try reversing it. So we do a translation down, right? Down 2, so it gets back here. And then a reflection back over. Would that work? I think it would. I think that sequence would work. Okay, and if you're not sure, we could always try it. So translation, right? There's our, oops, translation. We went down 2, right? Then we did a reflection for this, and why is that? Maybe it's like a double clicking thing. There we go. And I clicked translation, didn't I? There we go, reflection. I want this one, right, this figure. And then if I reflect it, and this is the difficult part again, is trying to find the right line of reflection here. Ah, so close. So notice it's kind of one of those weird guess and check situations where we're really, oh, there it is. Can I see how it, there we go. So yeah, it maps if you reverse the sequence. Nice. All right, so a figure is called congruent. So a couple of you asked me, what does congruent mean, right? And I used that word earlier in the last couple lessons. So when we're talking about rigid transformations, to summarize everything, when a figure is called congruent to another figure, if there's a sequence of translations, rotations, and reflections, it takes that one figure and maps it onto the other. All right. Take your 2 hands, right? Hold them out and touch your thumbs together. Now, what I want you to do is I want you to basically keep your thumbs touching one another as you reflect one of your hands onto the other. Does your hand map onto the other hand pretty well? Right? So your 2 hands are congruent to one another. All right, very, 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 very similar. I mean, there might be some minor, cuts and scratches and scars, but still, congruency is pretty much your left hand to your right hand in most cases. So a rigid transformation is a transformation that doesn't change measurements on any figure, right? If you move your hand to the right, it's still the same size. Move your hand to the left, still the same size. You reflect your hand, right? Make sure you don't twist your wrist. It's going to be the same dimensions, all right? So nothing's really going to change on that. All right, it's not going to blow up into a balloon and pop, right? All right, so the result of any transformation is called the image. All right, so if I ever say like, oh, what do you guys notice about this image? For example, ABC, triangle ABC, to triangle A prime, B prime, C prime. This is an image, okay? Triangle ABC is considered a pre-image. And then you can do multiple transformations, all right? So triangle ABC translates to the right to create triangle A prime, B prime, C prime. And then it looks like it translates from this image to this new image, triangle A double prime, B double prime, C double prime. Okay, so that's basically it. Here are the main words: congruent, right? Image, reflect, rigid transformation. So distances is preserved within the transformation, within the movement. That's what it means by rigid. Translate, all right, and that's sliding over to the left, right, up, down. Okay. All right, that's it. Have a beautiful day. Thank you.